Alrighty, I might kick off. Hey, welcome to this Cloud Track session on making DevOps work in the wild. I'm Hamish Watson. I'm really looking forward to hopefully showing you how to make this DevOps thing work in the wild or work in the real world. Alrighty, I'm Hamish Watson. I'm from Christchurch, New Zealand, which unfortunately for you means that I have an accent. You'll have to excuse me if I say Azure wrong. We say Azure back home. And what I've tried to do in my head was think of Badger, Azure. If I speak too fast, please let me know. Just raise your hand. I'll try and slow down. I've been working in IT for 6,659 days, which unfortunately for me means I'm not a child prodigy. I've been doing it for quite a while. I manage SQL Server. That's sort of my core day-to-day job. I've been managing it since SQL Server 2005. And I'm in charge of making stuff go at Jade Software Corporation. What that means is that I'm an ops guy, operations manager there, but I actually send all my staff on a developer course. And the reason I send my my ops guys on a developer course is one, for my pure enjoyment. They have to spend a whole week learning C#. But more importantly, it means that when those ops guys talk to dev guys, we've got a little bit of commonality. I also, as part of making stuff go, one of my prime directives is to keep solution architects honest. I like to think of myself as a pragmatic architect. They design brilliant solutions, I make them go. I'm a leader of SQL Server user group in Christchurch. I'm a SQL Saturday speaker and organiser, and I was lucky enough to be a past Professional Association of SQL Server Summit speaker last year. The reason why I get up in front of people is because I want you to learn from my mistakes. I've made many mistakes in the last 6,659 days. So if I can, inspire you not to make those changes and you hopefully learn something, then this has been well worth the trip from Christchurch. What are we going to do today? Well, we're going to demystify that DevOps thing. You've probably heard of it at conferences. People sometimes associate it with marketing and C-level type executives. We're going to discuss some of the tools because we're all technical people. So we're going to talk about some of the tools that are going to help us. Azure is the platform that really is a game changer in this and allows us to get some efficiencies. More importantly, we're going to bring continuous delivery to your database and apps. And we're going to do that via the in the wild or real life demonstrations. During my session, I want you to be engaged with me. So I'm going to tell you some fun facts about my country. One of them is 75% of New Zealanders living overseas live here in Australia. It's a little known fact that the Gold Coast is New Zealand's third largest city. There will be an exam at the end, by the way. I have some cool prizes. Right, a brief history of why my company started looking at this DevOps thing. We had little source control. We had great developers, but our source control systems weren't there. And that led to actually little control, because when that brilliant application that was being coded by our developers was passed over to our ops or DBAs, it was a little bit painful. And what happened was we got some silos there because we didn't trust dev didn't trust ops, and almost no one trusted DBAs. And this resulted in a term that I've heard called fear ops. Fear ops involves beer, pizza, and late nights, which sounds awesome, except those late nights, developers, DBAs, ops people huddled around computers trying to work out what has gone wrong, because we're doing manual things and we're putting things into the one environment that really matters. That's production. And we've got this whole bank of configuration changes and we've got to put it into prod. And unfortunately, we're scared that it's going to break. So we don't actually like change. And we certainly don't like automation, because if we can't trust developers, DBAs, and ops people, how the heck can we trust the machines? Something had to change, because these late nights at 3 a.m. in the morning, where all of us were huddled around and trying to make stuff go and weren't, was not a great way of spending 3 a.m. in the morning. I'd rather be doing other activities at 3 a.m. in the morning. So really quickly, what is DevOps? Because you've probably heard of it, and Wikipedia talks about it. DevOps is something that will solve this issue. The issue is that developers have a bank of changes, a bunch of features that are innovative and what the client wants. Operations people want stability. We don't want prod to break. And so inherently what happens is there is a silo between the two teams. And it's actually a power struggle, because operations is measured by stability. Developers are measured by innovative changes. There are also a lot of buzzwords in our profession. And, you know, one week it might be DevOps, the next week it's cloud, gamification. And you will see a lot of terms associated with DevOps. And what I want to do is try and get rid of all the misconception around DevOps in the wild. So for me, DevOps is around a couple of philosophies. And one of the ones that underpins it is culture. And don't worry, this is a technical session. I'm not gonna get you all to stand up and hold hands and introduce yourself to each other, as happens. But culture is about focusing on people, and people who want change and innovation and standards. The next term is automation. We don't want to do anything manually. The reason why we don't want to do that is because humans make changes. We're a brilliant species, but we're not as good as machines. So we want to automate everything. We want things like infrastructure as code. We want continuous integration, continuous delivery. Lean, that lean thing, right? So we want small iterative changes put out to our system. We want to build fast, but there's no point building fast if it takes 2 weeks to get the ops guys to build the infrastructure. So one of the parts of this is being agile right across both developers, DBAs, and ops. And measurement is around measuring things, finding out how our apps are going, getting feedback on our apps, giving that same feedback to our clients, being able to give our clients, either in-house or external, a measurement of how the app is going, how our deploys are going, which leads into the last one, sharing. This is around being able to collaborate and communicate, being open about what we're doing. Basically, by doing these, if you look at the CALMS, it kind of calms us. And as you'll see during this session, DevOps is around the same language. So we all speak the same language, but we speak different dialects. And what I mean by that is we all have a common goal, both developers and ops. That is around being able to deliver reliable software in an automated way. And to be honest, only the name is new. You know, this DevOps thing has been going for years, decades. And so one of the rules I have in my company, the first rule of DevOps is never say the word DevOps. There were 2 questions that we asked ourselves about what we were doing. And the first one, believe it or not, actually siloed us. Because in this sentence that you're reading, you have the developer side and the operations side. A better question is about the goal. And what we're doing here is having a common goal. Again, around being able to deliver to our to our customers and shareholders? So we went with the second question. It's important to acknowledge the first question though. So here it is. This is my, in the wild, the real world definition of DevOps. And again, don't say the word DevOps, because we could spend hours. We could spend actually a whole day, and we did, debating what DevOps meant. And so what we realized, it was about all these things. All the continuouses. So what we have is, say, we needed to implement continuous integration. We needed continuous testing. We were doing testing, but it was manually, and it was at the wrong part of the deployment pipeline. Continuous delivery, being able to push out our releases almost immediately, being faster to respond. Continuous monitoring gave us the ability to monitor the performance of our application or database earlier on in the piece, and you'll see what I mean by that soon. And the cool thing is, we live in a very insecure world, so if we can take security and fold it into continuous delivery, we're going to be ahead of the game and we're going to be secure. So I'm going to ask a question. How many people in the room already do continuous integration? Okay, maybe a third. Continuous delivery? A little bit less, but that's cool. Alrighty, so the last one is bringing all of this together, because it's all very well and good having continuous integration, continuous delivery in your deployment pipeline, but if we're not collaborating and communicating together, and when I say together, I mean all the stakeholders in our business, right? So our marketing people have a place to play in this, because they're going to feed new lines of business, features, what have you. And the last one is chat. And what I mean by that is talking with people. It might be over the water cooler, but having continuous chat about what you're doing actually really helps in our architectural design informally. What are the benefits? Because we don't want to do something unless we're going to get measurement of what it will do for us. And one of them is enhanced customer experience. And what I mean by this is we're engaging continuously along our development and deployment pipeline to obtain feedback. And by obtaining that feedback, it allows us to react and adapt to what our clients need. And so if the result of this is a more stable and reliable deploy and a more stable and reliable app, our customers are going to love that. And more importantly, they're going to pay us for loving it. And it's going to garner some loyalty from our customers. It's also going to allow us the capacity to innovate. And what I mean by that is, instead of doing manual things where humans make mistakes and we've got people up at 3 a.m. trying to fix things before the business comes online in the morning, those people are not doing that wasted rework. They're being able to do higher value activities, which means instead of being reactive, we're now moving into being proactive. And that allows us faster time to value. It means that we can, again, react and adapt quicker. We can push out our changes. We can push out our apps quicker than the competition. That's got to be a good thing. There are 4 pillars of DevOps. There are 4 things you need to consider. And I'll start with the one that we all love. I love tools. I like doing technical things. I wouldn't be in this game if I wasn't. But here's the deal. We had the tools, but we didn't have the process. Our process was around doing manual things. And so what we did was we collectively looked at our process. We collectively collaborated on what our process should be. I'm an ops guy. I want backups. I want more backups. I want to actually back up the backup, please. Whereas developers want to push things out as quick as possible. So we had to fine-tune our process. And at the time, our process was largely manual and disjointed. here's the deal. We needed people. We needed the right kind of people. And so in the wild, I found a like-minded developer. By the way, we are going to do demos in this, and I will show you some of the things that enable us to do tools and process. I found a like-minded developer, and we worked together through the process. And what happened was we grew in numbers. We started off with 2. We grew to a team of 45 people who were keen to have a culture. If you focus on one of these things, because it's not just all about the tools, it's not just all about the process, it's definitely not all just about the people. You have to do all 4, and you have to acknowledge all 4. And we're technical people. The last one's the worst one, because we don't like that. We're somewhat introverted. But being able to get past that, because if you only focus on one, you're going to do it wrong. Because here's an analogy I like to say. We have the right tools, but the process fails because the people don't get the culture. Don't worry, this is as far as we'll go with culture in this session. Because to bring you back, to keep you engaged, we're going to talk about tools. Fun fact number 2, only 5% of New Zealanders' population is human. The rest are animals, and please, no sheep jokes. There are quite a few DevOps tools out there. I studied chemical engineering at university, so I always like a bit of periodic table. It reminds me where I've come from and why I got into IT. There are so many tools out there. You and your team and that other team need to find what's best for you. By the way, this is put up by Expia Labs, and it's really cool. You look at it and you look at all these tools. It's a little overwhelming. What you need to do is start small. Find the tool that works for you, that will fit with your process. One of the tools is infrastructure as code. And I've used Azure PowerShell as an example here. This is an actual example of a VM that I spun up in Azure. And one of the things about infrastructure as code, it means that we're taking the humans out of the equation. It means that we are able to spin up resources, be it a VM, a database, an app, what have you, in a manner that is declarative, reusable, automated, and testable, because we need to test stuff. And infrastructure as code means that we can get fast feedback, because we can spin up resources in seconds to minutes that would have taken a week or more, having to get operations to spin it up. They've spun it up wrong. We need to do this, that, and the other. And one of the things we did was allowed our developers to spin up their own VMs in Azure. That sounds scary to most ops people who don't get this. Because what we want to do is to enable our developers to be able to spin up resources as required. Don't worry, there are parameters around this so that they can't spin up the biggest, baddest server. But what it means is we are enabling them. And the cool thing about Azure are the templates. People have already written this for you. I grabbed this template. Within 5 to 10 seconds, I'd plugged in what I needed and handed it to our developers. Infrastructure as code, by the way, is up in source control. This isn't just something we just do. We do it in coordination with our deployment pipeline. Let's say you have an application at version 2.0 and you've got a server that's been declaratively designed at 1.5. Well, you can now tie those in your release, because how many times have we deployed an app that relies on features in a server that someone installed on Friday afternoon, and Monday you say, hey, I need that again, and you get a wholly, completely different environment. And what helps us not do that is by having this in our source control, having it versioned, and being able to give the power to our developers. That's going to make things a little bit crazy, because now we're spinning up stuff all over the place. And what we're going to experience is something called drift. because I've created an environment in September last year, and now, over the past however many months, 5 months, things have changed. We've put new packages on. And so what we need to do is do configuration management. We need to ensure that we can declaratively configure our software. The DSC stands for Desired State Configuration. It is a module in PowerShell. If you're not using PowerShell, if you're not au fait with PowerShell, you need to learn it because the world is changing, especially on Windows Server. PowerShell is so powerful. Desired state configuration allows us to manage our drift. It allows us to install packages automatically. Tying it in with Chef, one of our sponsors here at Ignite, means that you go next level. And this is a script that we're looking at servers. We're applying this to servers to see if a backup user is there. So that again, we're not having humans do this. Right, let's look at the tools. Because what we need to do is some of these things on the left here. We need to manage our workflow up the top there with task tracking and issue and bug tracking that our clients are going to feed into. We need source control. Quick show of hands, please. How many people use source control? Oh, yes, most of the room. I always like to think of source control as breathing air. Without source control, you're breathing dirty air. You'll still survive, but after a while, it's going to get painful. Source control is like breathing clean air. It helps us. We need an integrated development environment. So, you know, your Visual Studios, this, that, and the other. We need to automate as much as we can. And as I said before, our testing, which is fundamental, we need to automate it. And we need to automate our release. There's no point having all these other things and then doing a manual release. We're not going to realize the potential. The cool thing is, there's some tools out there for you to do it. So in the Microsoft space, we have Team Foundation Server. You might be running this on premises, but the world isn't perfect. I'll wait for it. Yep, because there's a better photo now. This is the real world. You might use some other things, and that's okay, because some of these things are open source, and we're down with open source these days. So you might actually have your source control repository as Git. The cool thing is, TFS, Team Foundation Server, and Visual Studio Team Services interface brilliantly with Git. They also have their own repository, but you can do this. Let's talk about continuous integration. What I have here is a developer who writes some code. It's committed up into our source control system. We've got another developer who writes some code. And what happens is our continuous integration server is going to check the code and see whether or not it fits our testing regime. And the cool thing is, the developer is going to get an immediate notification that their code didn't work, that there was a build failure. So they're then going to rewrite it. It'll do that process. Hooray, it passed. Now we're ready to completely build it and deploy it. Don't worry, the developer's probably done some unit tests on their local machine, but they wrote the unit test, so it might pass. Let's not leave ops out of this. Operations are going to follow the same process as dev. They're going to use source control, and every ops person's going to hate this, but they're actually going to use agile. Infrastructure as code is a collaborative winner. It means that the ops guys can actually spin up, when working with developers, the resources that they want, rather than just going, you're getting this. Azure, PowerShell, and desired state configuration are things that we in ops are being able to change how the business goes. And products like Ansible and Chef really take this next level. You have to understand PowerShell and desired state configuration first, you know, that's sort of your learning blocks. but these products can really build things for us. I got a couple of special mentions. I'm an ops guy, I'm a database guy predominantly, and SQL Server Data Tools is allowing DBAs to do some of the things that those web application developers do. And DevOps is not just for them. It means that DBAs and developers who interface with databases can now utilize continuous integration and continuous delivery methodology. The DAC pack. I love the DAC pack. It's allowed developers and ops to facilitate iterative changes. We can now model our database. We now have a standard way of making changes. And here's the deal. Let's use source control. So where possible, I will say where possible, database activities should be in source control so that we can roll them out in a managed fashion. Another special mention is Docker. This was traditionally on Linux. It then appeared in Azure, which was awesome. And we now, as of Windows Server 2016, can run containers on Docker on 2016. And what this allows us is that we can fuse our packages together, we put them into source control, and then we publish that container image. And in particular situations, we can deploy the same image on Linux, on Azure, and on premises on Windows Server 2016. Some examples that we're doing is Team Foundation Server Agents. We're running these on Docker on Windows Server 2016. This means that this particular Docker image relates to this project. So we spin up these build parameters for it. This one over here has different parameters. It's a different image. But again, it's up in source control and we push it out. And we're moving towards where we can spin up tiny little environments. The thing about this is by deploying the same image, we're having consistency. We have a consistent artifact and we have a consistent environment creation. So what I'm going to do now is move over to the other computer and show you a demo. So what I have here is a server called Carlsberg. I don't know why I chose that name. I've logged onto it, and what I'm going to do is show you what is running on Docker. So we have a container there. It's currently down. So what I'm going to do is start it up. Over here, we have our TFS server. In fact, that was a Linux agent. You can do that as well. And we already have an agent. So what I'm going to do is run up my Docker image, which started immediately. I'm just going to show you this to show you that I'm actually in that. This all looks very familiar. This is running on server core. So what we're going to do is configure a TFS build agent on this Windows Server core machine. So we've got a couple of parameters that we want to fill in. By the way, I recorded this so I could talk more. Because who wants to see the top of my hair? Because there ain't much hair left, so, you know. So we're going to label our agent. This is standard, build that you'd ever do for TFS build agents. So I'm being able to run this, and here we go. In TFS, it's there. What that enables us is to push out images across multiple servers. If a particular project has a dependency, we don't have to install it across a whole server. We don't have to have these massive servers running multiple build agents and everything breaking. We just push out an image. So what I'm now going to do is a demo of continuous integration tools. I'm going to choose TFS and VSTS. So what we have here, I'm going to open up a solution. This is a little client portal, and I'm going to make some changes so that you can see me being a developer. I'm going to connect to TFS. So I have no pending changes. Here is TFS, and what we have is a couple of releases, and those releases relate to this particular application. And it's a real application. I normally show this, I click log on just to show. And what has occurred is we don't have enough photos. We only have one photo. So what we're going to do is write some code which will push it up to TFS here, and we have a number of build steps that developers and ops have collaborated about. So what we're going to do is put in some new pictures into our carousel, because marketing have said, we need more picture. So we're going to do that. So we'll save that, and the cool thing is, it's been detected as a change. But we're also going to do one other thing, because I want to show you at least two things. Marketing had also said, hey, there's not enough brand. We need JSC, Jade Software Corporation. Right, so we'll do that. And again, so yeah, it only says log on to your account. We want more. So we've made the change just there, which will be here. It's kind of weird watching myself do this. So what we're going to do is push this up into our repository, and our source control repository is in TFS. So we'll type some stuff really quickly and make it meaningful so that other people can see. Yep, we'll check it in. So change set 27 is successfully checked in. And what we'll do is we're going to go watch it. So hopefully we have a build which is queuing up, which is here. So it's 1.130. And while you guys watch that, I'm going to take a photo, because this is the largest amount of people I've ever spoken to. Okay, the cool thing about this build process, again, it's a collaborative effort, and we can see some logging. There are steps here. We can see what they're doing. And what we're going to do is push our package up. And it's version 1.30, which has gone over. So, sorry, and it'll be kicked off on our build agent here. It succeeded, which is really good. So this is a good thing. So what it means is that as it goes through our deployment process, we now have more pictures. And we have down here our JSC account. And again, the particular build steps. So we have our studio solution build. We are copying files from our repository out to where our artifact is going to be deployed from. We then deploy it out. We push the packages to our release manager or deployment engine, in this case Octopus Deploy, and we create our deploy or release. We're now going to look at VSTS. So this is the online version. We're going to interface with this particular website here. It's up in Azure as well. So this is the whole Azure experience. And what we're going to do is take the changes that we pushed into our CI environment, our continuous state integration one, and push them out into what we've called integration up in Azure. So we want to make some changes. So again, this particular system will open up our solution, and what we'll do is we're going to make some other changes. This system is living up in Azure, and what we're going to do, just to make it completely different, we're going to change the on to onto, and what the heck, we'll just put Azure in. And what we're going to do, again, is push that up into our source control, and in this case, it's in VSTS. So we're going to do this particular change, and we will connect to, again, VSTS up in Azure. Our pending changes are 1, changing the wording of the login, and push it up. The cool thing about VSTS and TFS is they have commonality. They have the same look and feel about them. And so it's a common view. So moving from TFS to VSTS, you're going to see the same things. The build agents up there are hosted in Azure. You can also have your own on-premises build agents if you so desire, and they will interface. So we're waiting for our agent to start. Here's the hosted agent. As you can see, I've been doing many practices. And what will happen now is it'll kick off when it's available. And here we go. So again, we'll get our sources. We'll do a NuGet package restore of our dependencies. And while that's doing that, again, let's look at commonality. We have the same type of steps. The build steps in VSTS and TFS are extensive. People have collaborated in the community and allowed us to build on what they've done. I don't have to, reinvent the wheel. So again, we have different steps. We're going to do our VS build, and again, the same thing in VSTS that we have in TFS. So our build is happening. This is great. As you can see, time is flying by. And we're going to push it up into an online deploy management piece of software. And what we're going to do is we're going to deploy it straight to Azure. We're not going to deploy it to a VM or anything. We're going to use this Octopus Deploy, which is a deployment manager in the Azure marketplace. And it allows us to deploy up. And so we've got some logging, which is always good. The actual process itself is we're just going to push things up to Azure. And as it's finished, we're now going to hit refresh. It now has Azure, which is what we did in our solution. So this enables us, again, so it's similar to what we were doing here. Okay. So that commonality of TFS and VSTS is really good because you can do the same processes. But unfortunately, continuous integration isn't the whole story for reliable deployments, because we did CI, but we banked up 3 months of changes because we couldn't do the deploys. And unfortunately, when we pushed it to prod, it failed. So I'm going to talk about shift left. And what it's about is we're doing CI. We're going to push immediately to our CI environment or our build environment. We're going to get immediate feedback if something's wrong. And if it passes CI and build, we're then going to push it out into other environments. And these environments could be run up in cloud services, up in Azure. We don't need big resources for our integration and UAT systems. But what we do want is prod-like systems. We want to test continuously across our systems. What I mean by prod-like is that the same structure that prod has, we will have all the way through our systems. And prod might be a 1 terabyte database. We don't need that down in CI and build. That might only be a 50 megabyte database. But it's going to have the same schema. It's going to have the same services. And all the way through this, we're getting feedback. And if it passes all through this, we're then going to push it through to prod. And the cool thing about this is that the app is tested all the way through in an environment as close to prod as we can get it. So that if we get anything along the way, we halt, we fix it, and then we push out immediately because we know deploys can be in seconds because we just push a button. And what it is, the aim here is automated, reliable, repeatable deploys. It means that in prod, it's boring. we know it's going to work. I have a saying where I want to fail lots in CI and I want to celebrate lots in production. This is pictorially our CI environment right through to production, and as you'll see, we have the same deploy all the way through. In CI, we've got version 4.0. Thing is, 3.6, 3.7, 3.8 may have occurred, but they're not important enough to push out. We're actually going to push 4.0 because we've had the feedback, we know what we're doing. Alrighty, what I'm going to do now is do a demo on continuous delivery. So this is taking the magic of CI and really making it go out into CD. So what we have here is our good old system, our CI system, and what we're going to do, the system that we pushed all the picture changes to and we changed the count stuff. This is our CI environment. Here's our build environment, which hasn't had the deploy to it yet. And as you can see, we don't have any picture, and it still says the old type of stuff, whereas CI has got all the goodness. So we need to change build. So in this scenario, for our client portal, we have some variables, and any release manager should have variables in it. The reason for those variables is so that we can collaboratively set them up, and we can see all the variables, all the application settings in one place, and some we can't see. Even if we take off the sensitive button, you still can't see them. And so we'll build these variables up. You know, we know what our application name is, because how many times have you gone to look at an application, you're not sure what the app name is? Well, by having a central repository means that we can go through the process, we have everything in here. I'm an ops guy, so I love a bit of backup. And that backup step that we worked on has all variables. There's no hard coding here. So that means that we can punch out the same process across all those environments. So here we go. We're going to deploy to our build environment. And it's going to go through the different steps, deploying the database. So if I chose to see where everything's at, I can click in there. But more importantly, developers can click in there. It's all about sharing the same information across the two teams or more teams. The person looking at this might be a functional tester. They might be a QA person. So we've deployed it out. We've got all ticks. So let's have a look at our build environment. Hooray, we have more picture. This is a good thing. We're basically just putting out the same deploy, the same small iterative changes. Because CI is about merging small changes continuously so that we can push them out. But our functional test environment, we've had a request that we need a functional test environment. How to do a functional test environment means that we need standards. And here's some standards. You might be able to tell that we have a website, a web app here. We have a database app. And this is a CI environment. The reason why it's called that is the letter C. We have some standard security stuff. None of this was set up by a human. This is the Willy Wonka of setups. No one touched the server. So we have some standard setups in IIS. You know, I can tell which is the client portal system because all the names match. We match the IIS user right through to the database. So that when I have to resolve this, I can do the 20-second rule. Within 20 seconds, I know what connects to what. How many times have you been where you don't know what user is connecting to your database? By having the same standard right the way through, within 20 seconds, I can do analysis. I know where I sit. So, build. Funnily enough, it has a capital B for build. That's our standard. Your standard's far different. But again, I can tell this user for this app resides on disk in this directory with this directory structure. Same directory structure all the way through. Again, same web app. So what we want to do is now look at our releases. Here's the deal. You can see all the things that I have done. Information, collaborative information, so that other people can see what I've done. So let's go to TFS, because this particular application has been up in TFS. Again, we link it. That's my application. It's this source branch, this source version. All this information means that we're not second guessing. So what we're going to do here is we're going to create a functional test environment. So we have our CI environment. Oh, sorry, no, we're going to monitor. Continuous monitoring that I talked about before, being able to tell whether our database is up. Is it okay? What was, how long did it take to access the database? You might think that 3 seconds is horrendously long, but it's only a CI environment. It would be good to have a standard. This is our production environment. Now you might notice that 3 seconds is 20 milliseconds. You always want that in prod. And so we have, again, the same monitoring right throughout. So this is CI way deep in our deployment pipeline. Way up in prod, we have consistency. And look, this is an example that I have. For our monitoring, we monitor all the background services. So this is continuous monitoring of back-end services. Again, being collaborative, having information out there that people can see. And those people will be the client. They might parse this into their own application performance monitoring. You know, some people don't like that, but I do. What have I got to hide? So we're going to look at our functional test environment. It doesn't exist because I haven't created it yet. So what we're going to do is create it. Does it exist? The DNS doesn't even exist for it. So I'm going to set up the DNS for it. I'm going to set up the directory structure, the database, everything. And we want it standard. So we're going to have a step here called create standard environment. This particular server lives up in Azure. This is the server here. As you'll see, there's nothing on disk because it doesn't exist. There's nothing in IIS. No app pools, no sites, nothing. And so what we're going to do is use our standard process of creating a standard environment. Our functional test system, as you see down here, lives on this particular server. So being able to see where our resources reside. So let's do it. Let's create a standard environment. And again, I'm not doing anything. I just hit deploy. Normally I'd walk away, but we're going to watch it. And so we have information here. We're running some PowerShell that is creating our environment. We've got a green tick. Lo and behold, on our server, we have a directory. And again, we have the standard permissions. We have in IIS a new website with the same application, same standards of app pools with a user, and up in Azure, we have a database. But as you see, it's empty, because all we've done is just created it. We haven't done any of the goodness yet. So what we need to do, oh, by the way, I always have a hello.html. The reason I have that is so I know IIS is okay. Because how many times do you go to deploy something, it doesn't break, and people blame IIS? So I always like a bit of hello. So what we're going to do now is redo this deploy. Normally, I would do this deploy the whole way through and let all the steps happen, but we're actually going to skip that create one because we did it just before. So what we now want to do is deploy all of our changes. And this means all release 30, 31, 32, 33, whatever. And that's coming through. And the cool thing is, again, we can watch the steps if we need to. We can also look at logs to see what is happening. And the most important thing here is we're touching our database up in Azure. It's creating all the things that we need for this app. And again, it's all automated. It's all reliable and repeatable. And if it isn't reliable, it stops and we fix it and we immediately deploy again. So it's finished, it's worked, and what we have is some tables. Brilliant. So now what we're going to do is hit up, when I get there. So let's take out our hello, which tells me that iOS is working, and now we can see our application. We have the pictures, we have the changes that were run through CI and build environments. And I have the same monitoring, the same heartbeat pulse that we have. Okay, so this took 6 seconds, but that's okay. Because again, for this particular environment, I don't need huge servers. I just need something to spin up. And by using Azure, I can spin up tiny resources that cost me nothing per month, but allow me to do continuous delivery, continuous monitoring, and what have you. So we took something from CI to functional test. You might be wondering, why didn't I do Team Foundation Server all the way? Well, unfortunately, we don't live in a perfect world. In our particular example, we acquired some companies and they had their own CI servers. So what we did was we just folded that in, and our continuous delivery portion of this meant that we could take all the different CI servers, but they all had the same process, right? We still did the same kind of CI process within them. It doesn't matter about the tools, but by having a standard way of deploying it out meant that we could fold this in, and having, again, a central repository that all our build servers fed into meant that we didn't cause pain, but we still followed the same process. Fun fact number 3, no part of New Zealand is more than 128k from the sea. So how can Azure help with all this? Well, economy of scale. I can spin up a little server and it only costs me $3 a month, say, for my smaller environments. It's innovative. The marketplace is growing daily and automation is key. Azure has so many templates that you can use. I like to think of it as infrastructure as code plus. Templates, templates, templates. Go and use them if you haven't already. Go and try them. Try them out in your build environments, your test environments. Azure Functions is one that I'm really keen on using. This is where it's serverless. You throw some code up, it runs, it might use 0.0001 of a dollar of resource. It spins up and dies. It spins up, does its job, and then dies. Here's the cool thing. Azure, you can do a free trial. Sign up for a month. Try everything out to your heart's content, and then fold it in to your prod installation. All right, so I want to do another demo on how Azure is the game changer. And this particular demo is all about doing stuff in Azure. Sorry, I should be saying Badger, Azure, I'm sorry. Right, so I'm going to log into the portal. The portal is where I can see in my dashboard all my resources. And all these resources, you might recognize some of these. These are ones that I've been playing around with during our demo. We deployed to this particular one before. And here's all the information relating to it. I might have some application settings that I might want to store here. And again, setting these up, I don't do it manually. I run some PowerShell, Azure PowerShell. And within the portal, I can see all the settings. I can create the settings, this, that, the other, that relate to my database. So this particular app service relates to this particular database. And as you'll see, there are some other things here. So our good old functional test environment that we just created, this one here, relates to this database here. And as you'll see, there's resource utilization. So I can have a view of this very, very tiny change I did, because creating a table isn't that onerous in SQL Server. And the cool thing is, my pricing tier, I can scale up and scale down. So I obviously want to go right down because I don't want to pay much. But you can do that on the fly within certain tiers. And so down here we have a particular web server, a web database server. And these two particular systems here, we're going to look at them. This is my server that I just showed you in the Azure portal. And up in Azure, I've got two databases. One, a functional test database, and one, a QA database. They have some tables. One of the tables is Friends of Mush. It's a very empty table, by the way. My nickname is Mush. And so we have the same structure within our two databases up in Azure. And what we're going to do is eventually deploy to them. If we sort by name. And so here are the apps that are going to connect to our database. So our QA app service. So this is just the web app up in Azure. And as you see, I've been doing some things against it. Again, a common view. This is the URL. So here it is here. So I've got a build version there because I want to show you things changing. So nothing like a bit of number change. These particular app services, so we have functional test, we have integration, our QA environment. And what we're going to do is use VSTS, because this is the Azure demo, so we're all about cloud services. And again, we have some build steps. And what we're going to do is we're going to restore some NuGet packages, we're going to build our solution. We're also going to use DACPack, because I don't want DBAs saying that you can't do continuous integration, continuous delivery. So let's open our solution. This is a web app up in Azure, so I called it Azure Web App, just so I knew which one it was. I'm going to zoom in. We're going to make some changes. So nothing like changing a number from 46 to 47. And just to show you on the actual website itself, okay, yep, 47. And over on our page, in QA, we've got 46. We'll change it to 47. So we'll save that. It'll be a pending change. And we're also going to do some database stuff, because I've kept the application developers happy. I now got to look after my DBA friends. So we're going to create a table called Ignite Australia. We'll add that. The cool thing is, down the bottom there, you'll see some T-SQL. So I could do this via T-SQL. Questions raised. I hope people have questions at the end. It's not null. So yeah, I need at least one question, otherwise database is going to crash. So it's created our table locally. What we now need to do is to push that up to our source control. So what we're going to do is connect up to VSTS. We've got a couple of changes. We'll include them in. Always write something meaningful, like added table and change version number. That's always a good thing. So we've pushed that up. It's change set 47. So we go over to VSTS, and hopefully there's a build kicking off. There is the stuff I wrote, which is kind of nice for other people to know. And so while I'm doing this, so is every other developer. We're continuously integrating and merging our branches. And we're finding out sooner rather than later that our merge won't work. We don't find out in prod. So we're doing the build. I could have some some automated tests in here. And what we're going to do is we're going to use Release Manager in VSTS. It's really powerful. And what we're doing is deploying via Release Manager to our systems. I love log. I always like to know what's going on. And what we're doing is we're waiting for our build agent up in Azure. We have some separate steps here that relate to our release. We're going to do the DAC pack stuff. We're also going to deploy out to our web app up in Azure. And again, some logs. So at the moment, we're doing the database side. So we're running a DAC pack that I built locally. I pushed up to source control in VSTS, and now we're pushing it out. And in fact, now we're doing the web app side. So in real life, this takes about 2 minutes, but I wanted to speed it up a little bit. So it worked. We hit refresh. Hooray, it's 47. This is a very small change, and I didn't want to do anything too complex. Changing a number from 46 to 47 is about how good I am at application coding. Let's have a look at the database. We have a new table. No humans involved. It's a standard table. It's how we wanted it to be. Well, that's not all the story, because in our functional test environment, it's not there yet. And you'll notice that the build, as soon as it was built, it pushed the release manager and kicked off the release immediately because I chose to. I wanted to do a continuous deployment. So this again is telling us which database server SQL Server instance we're using. And lo and behold, functional test, once we refresh it, is 47. That's only half the story. Because what we're going to do is, again, look at what utilization we did. Look how much we used. We 0.27%. Again, not too much. But it means that we can monitor our performance. We can tie the APIs into this. And again, we have our table up in our functional test database. So what we're going to do is clone functional test, and we're going to create a UAT environment. But the cool thing is, I don't have to do much. I'm also not going to deploy automatically. So this is where change control, the thing that actually ties developers, ops, and DBAs together. We all hate change control. But by taking that tick off means that this will be approved to be able to deploy to this. And we can have variables up there. So VSTS does a central repository of variables so that we can all see what the variables are and we can collaborate and put them out there. And there's no manual editing of config files. It's driven by the machines. So we're going to create a UAT database. We're going to label it so that people know. We're going to deploy our DAC pack, which is in source control. We're also going to create a new web app service, UAT Azure Web App. More importantly, we're going to write something in here so that people know what we're doing. Because it's quite often not you who needs to look at this, it's someone else. So we're kicking off a release 21. It's going through our QA environment. It's not deployed to functional test yet. We can always check the logs to see where it's at. Most developers don't need to, because they kick off the build and go on to task number 2. If there's an issue, they're going to get feedback. So it's finished in QA. We're going to do this particular release into functional test. We know that it's going there because it's a different color. We can also check the logs if we so desire. It's worked in functional test. So what we want to do is kick this off into our UAT system, which has never been deployed to. There's no database. There's no web app. There's nothing. This is the first deploy. And again, no human hands involved. No manual anything. I'm pushing out a standard, reliable release that's automated and repeatable. So it's kicking off, it's doing some stuff, it's grabbing stuff. As you can see, we don't have a database yet because we haven't got to that step. So if we go back into our release, it's in progress. Let's see where it's at. It's executing the DAC pack now. This particular part of the process takes a couple of minutes. So we have a database, but again, we don't have anything in there. We've got to pump the changes in. Those changes are in our DAC pack. Those changes mean that the DAC pack will create the model for our database. It'll create the tables once it's finished. Still going. Here are the changes. I can actually see the changes in the log. So our VSTS administrator, if something went wrong, they could look at the log. And lo and behold, here are our tables. We have Ignite Australia. Hooray. So, we can also see all the changes that occurred in IIS up in our Azure box. Let's hit up UAT. Oh, by the way, if you are not using Kudo, look at it. It's awesome to be able to facilitate console changes or batch scripts. Here we go. UAT has been created. It has all the goodness that we had in our QA and FT environments. What this means is that we have the same release that has been put out. And UAT didn't even exist, but it got all the goodness. It got everything that we knew would pass. And yeah, it's built out of our source control repository. Okay. The takeaways from the demonstration is that testing occurs early with prod-like systems. We discover things early. And testing, automated testing, means more testing. We used to have a testing team of 4 people writing manual tests. We automated all that. It didn't mean that we fired 2 of them. 2 of them actually became developers. We kept the other 2 good ones to do more automated testing. Higher value activities. Some people say using DAC packs, oh, you don't need a DBA anymore. No, you need a better DBA. Because they're not now creating tables and doing all those horrible things. They're tuning SQL Server. See how it goes from being reactive, manual, to being proactive by automating things. Repeatable deploys actually does mean reliable deploys. And our repository of variables means that we're collaborating visibly. No hand touching of anything. The Willy Wonka factor. It's done by the machines. It means that we have less mistakes and we can trust each other and the process. Here are some numbers. It used to take us 4 hours to do a deploy. A lot of those hours were actually rollbacking, trying to work out what went wrong, redeploying, waiting for the deploy to finish, because we were doing everything manually. And as we moved across, by integrating CI, by using continuous delivery, and having standards, they're now 10 seconds. Thing is, our competitors are still around the 20-minute mark, and we're doing them in 10 seconds. It means that we can push this out to production very fast. I've talked about continuous delivery. There is continuous deployment. That is where I, as a developer, cut code, and once it passes the tests, it'll flow through different environments and go to production straight away. Okay, this isn't all good news. I mean, I can't just stand up here and tell you about magic unicorn fairy dust. We did do some things wrong. I don't have time for this. This is something some people said. That is correct, sort of. We didn't have time because we were working on wasteful activities. We were troubleshooting manual deploys that occurred at 3 a.m. People that are working at 3 a.m. weren't at work at 9 a.m., so they definitely didn't have time for it. And so by automating deploys, implementing standards, using continuous integration, continuous delivery, meant that we took out all those horrible things that are associated with deploys. And it meant that we could focus time on high-level activities. I also took a lot of people to the pub because we had to work our lunch hours because we actually didn't have some time to do some of this. So I said, look, if you will work with me, I'll buy lunch. And at the end of the week, let's go to the pub to celebrate. And we got there because that's part of the culture thing, right? We focused more on telling people where the toilets were and what was on their PC than what it meant to work with continuous integration and continuous delivery. And we had a PhD student join us. Man, they were so innovative. They had these cool ideas, right? but we didn't let them know what we were doing. And the problem was, a lot of people think you're using standards. You know, I had a standard user, standard database name, standard folder structure, security. You're going to kill innovation. No way. So we developed an MVC apps, right? We moved to Web API, and we even did stuff in Node.js. We innovated. But what happened was we caught all the issues in our CI and build environments because stuff failed, right? It failed miserably because our PhD student didn't know to do X, Y, Z. And so it taught us we need to collaborate on what it means to innovate. And here's the deal. By failing in CI and build, we made changes. And we made changes very quickly. And we succeeded. And then we pushed out to functional tests. We moved out to QA. We moved up to UAT. And we moved to prod, and it was boring because it worked. The game changes. Infrastructure as code, PowerShell, and SQL Server data tools for those of us that like that stuff. And DBAs love SSDT. Ops guys love infrastructure as code, and everyone should love PowerShell. Having source control interact with our build server. Because we had source control, but then we had to do stuff to get it going into CI. We worked out the pain points, we worked together, and now it was all automated. And then it folded into continuous delivery because our prod-like systems meant that we could deploy changes, find out all the issues before it affected our clients. I want to fail quick in CI or dev, and I want to celebrate lots in prod. The only problem is I've lied here because we don't celebrate lots in prod because we're deploying to prod at least once a week, and I wanted heaps of champagne and work didn't like that, you know. There's the whole HR thing. But find out all the issues really quick when it doesn't affect anyone. Azure, Badger. Spinning up resources is so easy, and it works in seconds, and there are templates. Use it. It's there to make your life easier. And the thing is, we achieved our goal for delivering maximum value to our clients. We achieved the goal of automated, repeatable, reliable, boring deploys. The future's awesome because we're going to use a lot more of Azure. One of the things is that microservices is an area where we need to look at because we're used to things living for hours, weeks, days, right? Well, now with microservices, those things only live for seconds. How do you secure that? And so a summation of this slide is use Azure. There are so many cool things in there. Use the free trial. Just try stuff out. But the thing is with Azure Functions, we had specialized cases, right? So we had a report generator that we wanted to throw 20,000 requests at. We only wanted it to live for about 2 milliseconds, right? So it spun up, did some stuff, spun down. And microservices on Docker has been able to give us scale and flexibility. If you see anything from the slide, it's the last line, don't be complacent. We couldn't rest on our laurels, right? So we'd solved some heap of pain using that D word, the DevOps thing. But we couldn't be complacent. We've got to keep going. Got to be ahead of the game. So to summarize, find a definition process goal that suits your team and company. I've talked about our one. Definitely start small. Rome was not built in a day. Start small and you will achieve greatness. We were lucky. We had a Greenfields application. Then we tried all this stuff out. We didn't try it on our legacy stuff. As we'd done it in Greenfields, we then folded it into our legacy systems. Keep focused on your goal. Our one was automated, repeatable, reliable deployments. Automation and source control really are your friends. And Azure really is a huge game changer, especially around infrastructure as code, being able to spin things up in a standard fashion. CI is key. Automate and test, and automate your tests some more, please. Just because we've deployed it isn't the end of the game. We've got to manage it. And so we've got to do the right things. We, again, have to keep our eye on the goal. And to be honest, even though this is a semi-technical presentation, it's not just about the tools. It's actually about you, and you, and you. But us. It's about communication and collaboration and culture. And I'm really sorry, I've kind of duped you because we've done a technical presentation, but I have culture as the last word. The reason why I put these here is because to make this go, we had to communicate about what tools we wanted. We had to collaborate about the process, and we had to have the same type of culture. And culture means a lot of it means something different to a lot of people, but if we kept our eye on the goal, it tied all that in. Lastly, today, this session is like a gateway drug. I want you to go to these sessions. I chose sessions that are after mine because I'm definitely going to go to them. I've given you a very brief overview, and I want you to go and discover this stuff, and I want you to continue to think about how you can do stuff better. Go to these sessions. I definitely am, because this stuff will honestly make your life easier. It's not just a buzzword. Don't get hung up on the word. Please continue your Ignite learning path. Visit Channel 9. And if anyone can remember the 3 fun facts, please come up and see me. I have some awesome New Zealand lollies that I had to smuggle through your very tight immigration people. I didn't do it like that. They were in my bag. And yeah, the Spark After Dark. You will have seen this in other presentations. Hey, look, thank you. Oh, sorry, you can clap. What a faux pas that was. They started about to clap and I start talking. As you can tell, I like talking. I like talking to make change. I've experienced so much over my 6,659 days. And if I can inspire at least one of you to make change, I am going to be in the speaker lounge and I'm there to help you. That's why we're here. So thank you very much for coming along to my session. Cheers.